Bismillahirrahmanirrahim. We are studying topic number 9.13, polarization of light. So, first we are defining polarization. The process in which we restrict a light into a single plane of vibration is called polarization of light. When we restrict a light into a single plane of vibration, that is called polarization of light. Remember, light is a transverse wave. Light has a transverse nature. It means its vibration is perpendicular to propagation. Remember, light is actually electromagnetic wave. What is electromagnetic wave? The wave which consists of electric field and magnetic field. Then magnetic field will convert into electric, and that electric will convert it into magnetic. So electric field and magnetic field will be perpendicular to one another and with the propagation. It means that electric field and magnetic field perpendicular to one another and with the propagation. So electric field vibration is perpendicular to propagation. It is transverse. Magnetic field vibration perpendicular to propagation, so it is transverse. So we can say that complete electromagnetic wave is a transverse nature. So that is why electric field and magnetic field has transverse nature. Okay. Now, remember, suppose we have a light which has a vertical vibration. We have a light which has horizontal vibration, which has this type of vibration. So light consists of many vibrations because light consists of many photons. So if light consists of many photons, so it will have many vibrations. Okay. Now, if it has many vibrations, so this light is called the non-polarized light. So it is non-polarized light. Why? Because it consists of many vibrations. So it is non-polarized light. Non-polarized light. Okay. So suppose if we have a light of this type of vibration. So look at this vibration. Here the vibration is up, down, up, down, up, down, up, down. So here the vibration is only up and down, means the vibration is only vertical vibration. So this is called the polarized light. Or look at this light. This light has a vibration left, right, left, right, left, right. So look at this vibration towards right, towards left, towards right, towards left, towards right, towards left. So these vibration is towards left and towards left. So this light is called the polarized light. So polarized light means in which the vibration is restricted in a single plane. So that is polarized light. So whenever we have different plane of vibrations, so this is non-polarized light. When we have single plane of vibration, that is polarized light. So it is also polarized light, and this is also polarized light. Okay. Now remember, only transverse wave can be polarized, while longitudinal wave can never be polarized. Longitudinal wave can never be polarized. Only transverse wave can be polarized. Okay. Now, if the question comes in the entrance test that which experiment are process proves the transverse nature of light. Option A, polarization. Option B, interference. Option C, refraction. Option D, diffraction. So remember, the answer is polarization. Why? Because if a wave can be polarized, so it must be a transverse nature. If a wave does not get polarized, so it has longitudinal nature. So it means that polarization is a basic difference between sound and light. Sound is a longitudinal wave and light is a transverse wave. So light can be polarized, sound cannot be polarized. So the basic difference between the longitudinal and transverse is polarization. Transverse can be polarized while the longitudinal waves can never be polarized. Okay. Now we have different method of polarization. Okay, now look at here. We can polarize by refraction. So the first method is polarization by refraction. The second is polarization by reflection. The third one is polarization by selective absorption. The fourth one is polarization by diffraction or scattering. Okay, so there are four methods of polarization: polarization by refraction, polarization by reflection, polarization by selective absorption, polarization by diffraction. Okay, so first we are studying polarization by refraction. Okay, refraction means when a wave enter from one medium to another medium, that is called refraction. Okay, suppose if we have a light which has vertical vibration, horizontal vibration, every type of vibration, so this is non-polarized light. So if we place a vertical slit, so remember when we pass this a non-polarized light through vertical slit, so look at here, the vertical vibration can be passed. Yes, vertical vibration can be passed. So it means that this is called polarized light, because only single vibration is allowed here and all other vibrations are cancelled out. So it means that only single vibration, that is vertical vibration, is allowed. So this is called polarized light. Suppose, let us take another example. Suppose if we have a light which has many vibration, up vibration, left, right, down, every type of vibration, so this light is called the non-polarized light. So we place a horizontal slit in front of this non-polarized light. So when this light passes through the slit, so only horizontal vibration will be passed, because this slit allowed horizontal vibration. So this is called the polarized light. So polarized light means when polarized light means when a single plane of vibration is allowed while the other all plane of vibration are not allowed. So this is called polarization of light. Okay, now here this is the polarization by refraction. Polarization by refraction. Another is polarization by selective absorption. Polarization by selective absorption. Okay, now we are studying polarization by selective absorption. So we have a glass that is called tourmaline glass. In chemistry, we called it iodosulfate. In daily life, we call it tourmaline glass. So it has good absorption of electric field. We know that electric field consists of medium. Magnetic field is also depend upon medium, but magnetic field is enhancing uh, by medium, and electric field is decreased by medium. So suppose when we have a glass, look at this glass carefully. This is these are the molecules in the tourmaline glass. Okay, so we have two type of vibration. One is the vertical vibration. Wait a minute, I am taking another pen. Okay, look at here, we have two pens. These are the two vibrations. Suppose this horizontal vibration is a electric field and this vertical vibration is a magnetic field. So we have a polarized non-polarized light because it has two vibration. One is the horizontal and the other is vertical. So this vertical vibration, this is the horizontal vibration. Suppose the horizontal vibration is of electric field and the vertical vibration is of magnetic field. So when these two vibration come and this vibration falls on the tourmaline glass, this two vibration falls on the tourmaline glass. When it falls on the tourmaline glass, so you will observe that the vertical vibration will passes in the tourmaline glass, while the horizontal vibration will be blocked by the tourmaline glass. So it means that the look at the vertical vibration will be passed while the horizontal vibration will be get absorbed. So it means that the electric field will be get absorbed in the tourmaline glass or in the medium, while the magnetic field will pass. If the magnetic field is passed, suppose this is the magnetic field, this is passed. So this magnetic field will change into electric field, this electric field will change into magnetic field, this magnetic field will change into electric, this electric will change into magnetic. So this is called plane polarized wave. So it means that single plane of vibration is allowed while the all other vibration are get absorbed. So this polarization of light is called selective absorption. This method is called selective absorption. The third one is polarization by reflection. Polarization by reflection. This is also called Brewster law. This is also called Brewster law. How we can define this law? Look at here. We are going to define this law. So the statement of this law is the relation between angle of polarization and a refractive index is called Brewster law. Okay. So Brewster took a crystal. He took a crystal and he incident X-rays on the crystal. These are the X-rays, okay, and these are the non-polarized X-rays are the non-polarized light, okay. So look at here. Okay, look at here. I draw the two lines. These lines are falling on the crystal, and these lines will be get diffracted in all the direction. These rays will be diffracted in all the direction, but I am going to study only one direction. So one X-ray is diffracted in this direction, the other X-ray is diffracted in this direction. Okay, the diffraction of X-rays in many directions, but I am going to study only one direction. So these are the incident X-rays and these are the diffracted X-rays. Okay, so I am labeling this X-rays as AB, and this is CD, and this is BE, and this is DF. Okay, okay, I'm going to find the distance between the two atoms of a crystal, that is small d. This is called small d. This is one atom, this is another atom. So I'm going to find the distance between the two atoms. Okay, so these are actually the incident X-rays, and these are the diffracted X-rays. Okay, so now I'm going to draw this diagram again. This is wrong. Actually, this was the diagram of Briggs law, which is excluded in our course. So I'm going to draw this diagram again. So this is the molecule of crystal. Okay, so this is the normal line. Whenever the X-ray come, this is non-polarized light, means this has many vibrations. So this is the reflected ray. This is the reflected ray, or this is called the polarized ray. This is called the incident or the non-polarized ray. This is the original path, but this will be bent towards the normal because this is the refracted angle. This is the refracted ray. So this angle is called the refracted angle. This angle is called the incident angle. This is called the polarized angle, because this ray is polarized ray because it has only one vibration. So if it has only one vibration, so this is the reflected ray or the polarized ray. The same thing is that. This is called the refracted ray. So this angle is the refracted angle, this angle is the incident angle, this angle is the polarized angle. According to laws of reflection, which we have studied in a matrix, incident angle and the refracted angle are always equal. This law is presented by Ibn al-Haytham. The incident angle and the reflected angle always be equal. Okay, and according to Snell's law, sine of n1 sine of theta of incident is equal to n2 sine of theta of refraction. This is theta of refraction, but we don't know this angle of refraction, so we have to find out this angle of refraction here. So remember, this angle is 90 angle. So this angle is 90 angle. If this angle is 90 angle, so this incident angle is called the Brewster angle. This incident angle is called the Brewster angle. If the reflected ray and the refracted ray both are making an angle of 90, so this angle is called the Brewster angle. This is the definition of Brewster angle. Our Brewster angle is defined as when the incident angle at which the reflected ray is completely polarized. That angle is called the Brewster angle. Okay, I'll define it later, but remember, I'm going to find this refracted angle. So remember, from one normal to another normal, the angle is 180 degree. Look at here, from one normal to another normal, the angle is 180 degree. So from here to here, the angle is theta p, angle of polarization. From here to here, the angle is 90. From here to angle, the angle is refracted angle. So if we sum all these three angles, polarized angles, 90 degree, and the refracted angle, so the answer will be 180. Okay, shift these two on the other side, so it will be minus. So it is minus 90 minus theta p. Okay, 180 minus 90, so it will be 90 minus theta p. So putting this value in equation number 1, 1. So equation 1 we will have, look at equation number 1. N1 sine of theta of incident is equal to N2 sine of theta of 90 minus theta p. Okay, this is the formula in mathematics. Sine alpha minus beta is equal to, look at the formula, is equal to sine alpha cos beta minus sine beta cos alpha. This is alpha, this is beta. This is alpha, this is beta. Sine alpha minus beta is equal to sine alpha cos beta minus sine beta cos alpha. Okay. Now, what is sin 90? We know that sin 90 is equal to 1. So it will be 1. So cos theta p left. What is cos 90? We know that cos 90 is equal to 0. And 0 multiply anything is 0. So it will be n1 sine of theta of incident is equal to n2 into cos theta p minus 0. Okay. So it will be n1 sine of theta of incident is equal to n2 cos theta p. Okay. We know that incident angle and the polarized angle are equal, means the incident angle and reflected angle are equal. So putting the value of incident angle here, so it will be theta p and 2 cos of theta p. Okay, divide cos on both sides and n1 on both sides. So we will get sin theta p divided by cos theta p is equal to n2 divided by n1. So sin by cos, that is called the tangent, and n2 by n1 as it is. So this is called the Brewster law. The angle of incident, the relation between angle of polarization and the refractive index, this is called the Brewster law. Okay, how we can define the Brewster angle? Look at the definition of Brewster angle. The definition of Brewster angle is the angle at which the incident angle, okay? Remember, Brewster angle is the incident angle at which the reflected ray is completely polarized is called the Brewster angle. This is the definition of Brewster angle. For the glass, the Brewster angle is 57 degree. So at 57 degree, the reflected ray will be completely polarized. So that is called a polarized ray. Okay, this is all about this Brewster law. If you have any question, then you can ask in comment section. Okay, thank you. Allah Hafiz.